Okay, yeah, so rate determining step. The rate determining step, remember, is the slowest step. And we're going to assume today that there's a two-step reaction. We're always going to assume that the slowest step is the first step unless told otherwise. And the question would make that obvious. There is a method. I'm going to get you to write it down, and then I will obviously go through it in a second. It's a bit of a chunky one. So step one, and this is how you come up with a two-step mechanism. Again, I'll go for an example of this after. The rate equation will tell you the reactants that are in the rate determining step. You can get that from the orders. Remember, the order of a reactant is the number of molecules of that reactant in the rate determining step. So by looking at that rate equation, it'll tell you what you have as reactants in the first step. So that's step one. You can then compare those reactants to the overall equation, and any reactants that are in the overall equation but not in the first step must be reactants in the second step. And then this third bit, this is the bit you're not going to like, because I have to say at some point, I can't help you here. You either kind of know the chemistry or you don't. And it's different for each equation. And if you get that down so you've got the method, I'll go through that in the example, because that's hard to understand without an actual example. Like I say, this is really, really useful. You can get so much information once you've got your mechanism. So probably what will happen is question A, they'll give you some graphs and ask you to come up with a rate equation. So you might need to use half-lives, you might need to use the shape. Maybe you'll need to use that big table method, the initial rates method, and that'll give you the rate equation. Once you've got the rate equation, question B would say, come up with a two-step mechanism. That's probably the way it's going to work. Okay, so as I'll go through one example, then I'll give you guys a few to try yourself. As I go through this example, just try and follow what I'm doing on your method so you can see how I've applied the method. So that when you do it, you can do the same thing. I'll probably move on in a second, but I'll flick back to after if you've not managed to get it all down yet. Okay, I'll promise I'll flick back in a second. Okay, so here's an example. So I've got my overall equation, 2NO plus O2 goes to 2NO2, and you'll either be told the rate equation or you'll have some way of figuring out. So I'll have K goes to NO squared. That tells me NO is second order. And we're going to assume there's two steps unless told otherwise. And again, unless told otherwise, we're going to assume the first step is the rate determining step. It might not always be. If it isn't, they'll let you know that. So I can look from my rate equation, and again, you can follow the method you've just written down, and I can say, well, my rate equation tells me NO is second order, so I must have 2 molecules of NO in my rate determining step. It also tells me O2 is 0 order, so there must be 0 molecules of O2 in my rate determining step. That's step 1. What do you think? Thumbs up, thumbs middle, thumbs down? Good. So we're using that rate equation to figure out reactants in step 1. Step 2, we now compare the reactants we've got here to our overall equation. Well, if O2 is a reactant, and it's not a reactant in the first step, well, then it's got to be a reactant in the second step. Otherwise, it wouldn't be a reactant. Yeah? So that's step 2, compare your first step reactants to your overall. Whatever's not in the first step, bang it in the second step. Now comes the tricky bit. And again, I can't help you here. You've got to kind of wing it a little bit, is what it is. We're going to react our reactants in the first step to make an intermediate. Now, will an intermediate show up in the overall equation? It won't, will it? Because it gets used up again in the second step. That's the tricky thing. If you can figure out what the intermediate is, you've probably got it. But it changes every time, so I can't tell you what it is. You just got to kind of look at it and go, it's probably that. You might possibly also make some of your products in the first step. Maybe. Sometimes you will, sometimes you won't. Regardless, your intermediate will then react with whatever your reactants are in the second step to make whatever product you didn't make in the first step. So if I leave you to try and finish that one off then, have a little think. Sometimes, although there's only one real answer, they will allow incorrect answers as long as they're sensible. Yeah, as long as it's a sensible answer. If you start talking about N7, right, they ain't going to be allowing that, right? That's not a thing. As long as it's a sensible intermediate, they will allow it. And ultimately, this will only be 2 marks, so I wouldn't be spending ages on it in an exam. You can get caught up in these, and before you know it, you've lost 15 minutes. Anyone thinks you've got an answer? Just pop your thing up. I'll try and have a check. I don't think I'll be able to see us at the back, but maybe at the front. Nice, excellent. That would be an acceptable answer. Yes, yes. It's not the actual one, but yeah, absolutely right. That's sensible. Yeah. Yeah. And just bang that in. And then bang your intermediate in the second step as a reactant. Because it needs to get used up again, doesn't it? Yeah, excellent. Let's go through it. So our, again, you either kind of know this is a molecule or you don't, is going to make N2O2. It's like that. It's a thing, N2O2. As this is not in the overall equation, this must be our intermediate. So the N2O2 will then react with the O2 to make our products. You can do a nice little safety check. If you cross out your intermediate, you should be left with your overall equation. That's what you should be. Now if you said this makes N2 plus O2, and then N2 plus 2O2 goes to this, even though that's not actually the correct answer, you'd probably get the marks for that. Because that's sensible, right? N2's a thing, O2's a thing. You're not to know that it does this, so that would be allowed as well. And others as well, probably. Yeah? Okay, let's try a couple more. So I did say I'd give you a few seconds to do that if you wanted to. 30 more secs to get that down if you didn't already, and then we'll move on to another one. Okay, all right. So there's 2 more here actually. Let's just try this first one first. Here's the overall, here's the rate. Have a crack at that one. See that one? Yes, we can. Possibly, yeah. So
Brady.
you can't do that final products until last. So get rid of all these products. I said, yeah.
With the, because obviously in the rate equation, it doesn't like tell you if you always put, because in this equation it's 2NO2.
Yeah.
Would this be 2NO2? Or would it
Is
just
that
be
first order or second order?
First.
So that's one molecule.
Okay.
If it was second, it'd be two.
Okay.
So the
So
order
the-
tells you the number of molecules.
Okay, so then in the second step there'd be another one.
There must be, because if it's not the first, then it must be in the second. Absolutely right. So fast and good, then, not it? If anybody wants me to have a check of their answer, by the way, just hold it up.
Can intermediate be like ionic?
It certainly, sometimes it'll be an ion. Yeah, sometimes. I wouldn't go down that route for this one as a heads up, but certainly sometimes it can be. They probably won't allow you to break it all down into elements that much, because otherwise you're going to have loads of different molecules needing to hit at the same time in that second step. So I see what you've done there, and it is sensible, absolutely, but I'd try that differently. You can't just break everything down into its elements, so you could do that every time, is the thing. Any more for any more? It's all about that intermediate, isn't it? That's the tricky thing, is getting that intermediate.
Should the intermediate always be one molecule?
Yeah, I mean, in reality, no, for this, yes. It will always be one. CNO4. What's that look like now? I don't know. Try, if you think you've got an intermediate and you're not sure if it's a real thing, try and draw out like a stick diagram of it and check if everything has got sensible in the box. If you can't do that, probably a real thing. Okay, one more minute, and I'll go through the first one. If you finish the first one and you think you've got it, feel free to move on to the second one. So, you've said in the first step, you've got two NO2, haven't you? But what order is NO2? So how many molecules of NO2 are in that first step? You said two. So it can only, whatever the order is of the chemical, that's how many of that molecule is in that first step. So is it one that, well, that's first order, isn't it? Exactly, yeah. I like it with that CO though as a product, yeah. I think this is one of the hardest things, by the way. I think this is really tricky because it changes every time. Let's have a look at this first one, see how we're doing. So, first of all, from my rate equation, and I'm just going to bring it up on the board there, I can tell that my CO2 is first order, there's one molecule, NO2 is first order, there's one molecule. By comparing what I've got in my first step to my overall equation, I can see there's an extra NO2 that must be in the second step, because that's not in the first step. So I can put my second NO2 there. Now comes the tricky thing. We need to make an intermediate and maybe some products. That intermediate needs to react with the NO2 to make the rest of my products. So you just kind of got to go for it. The intermediate is carbon monoxide. So the CO2 is given one of its oxygens to the NO2. And can you see how NO3 is one of our products? So we've made some of our products in the first step. Obviously we can't make every product in the first step, otherwise there wouldn't be a second step. We can make some of them. So what products have I got left over then? I've got a carbon and another NO3. So my intermediate CO reacts with the NO2 and gives its other oxygen there to make carbon and the other NO3. If we was to, it won't let me write on my whiteboard, but if I was to cross out my intermediate, I get my overall equation. Yeah. Have a crack at that third one. Yeah. Once you've finished that third one, if you go on today's lesson on the VLE, there's just a couple of tasks that kind of take you through this, basically. So again, in the first step, explain to me how you're going to know what's in the first step. What are you going to look at?
The rate equation.
So looking at this rate equation, what order is calcium carbonate? So how many molecules that must be in that first step? One. What order is hydrochloric acid?
Second.
So how many molecules that must be in the first step? You didn't put it in the first step. So the rate equation tells you what's in the rate determining step.
Okay.
The fact that HCl was second order means there must be 2 molecules of HCl in the first step. Yep. CH2O, what's that look like? Okay, yeah.
I don't know that's in the
Okay. Sure, yeah, I mean, probably they'd give you that. That seems feasible. You've made sensible molecules. Like I was saying earlier, try and only make one intermediate though. You see, you've made 2
Yeah.
intermediates. There's almost always only one. Certainly for what you're going to be doing, there's going to be one. But yeah, I think that sounds sensible. You might want to have a try it again though, but yes. Yeah. Of course, yeah. Like I say, if you finish this, which I'll go through in like 5 minutes, just on the VLE, lesson 1, there's a bit more practice of this. You've done 2 intermediates again.
No, that's the same one.
Oh, sorry. Yeah, sorry, yeah. There's an actual answer because this has an actual mechanism, but of course the example didn't expect you to have memorized every actual mechanism, so as long as you give something sensible. So they won't even in the mark scheme, the initial mark scheme, have every possible answer. They'll say something like, here's some other possible answers they might give, which is good, but also anything else that's sensible, give credit for that too.
So you just kind of have one everything.
It has to be actual molecules that exist. Everything has to cancel out to give you the overall equation. Yeah, so as long as it's sensible. Exactly, yeah. But you're on the right, you're getting there. So you've assumed that all products are in the second step. How do you do that? So that's what you do last. So before you can figure out what products are in the second step, you need to first figure out your intermediate and products in the first step. Again. Otherwise some of your products could be in the first step. Yeah. Exactly, yeah, perfect. That's it. Nice. Okay, let's have a look at this one. Definitely a tricky one. So, we know from the rate equation we've got 1 molecule of calcium carbonate and 2 molecules of HCl in our rate determining step. By comparing that to the overall equation, we can see we must have no other reactants in the second step. So would you agree, this is a little clue here, sorry, my throat's gone today. If ever this happens, would you agree this means that the only thing in our second step will be the intermediate? What does that tell you the intermediate must be doing in the second step? Begins with D. You could say, yeah, I was mean decomposing, but yeah, same thing, yeah, must be breaking down, right? That's something worth remembering. If ever the only thing in your second step is your intermediate must be something that can break apart, dissociate, break, whatever, yeah? So we need our intermediate to be something that can break down. It just works out the intermediate is carbonic acid, H2CO3. And if you do biology, you'll probably know this. Carbonic acid can break down into H2O and CO2. Let's double check. When I get rid of my intermediate, yep, I'm left with the overall equation. Yeah?
Do you not do like H2 and CO3?
H2, CO3 has a charge, so it would be CO3 2 minus, and then you wouldn't have a balance of charge between your reactants and products. If CO3 was a thing that you could make without a charge, yes, absolutely. It's just CO3 without the charge doesn't exist. So it's one of those things where it has to exist, yeah. But I can certainly see why you'd go there. Okay, guys, so have a crack, like I say, on the, we've only got like 15 minutes left. On the VLE, it just takes you through a couple of questions like that. It also does a bit of a recap on that big table method, so there's a bit on that too.